Yes.
Thank you. Okay. So one of the things is we had, do you have that sheet or do you have something like that in front of you that we can go ahead and start having a conversation about where we have right? So when we have our laws of exponents, we have, you know, a to the x times a to the y. How can I rewrite that as a to the? Anyone?
Sure.
A to the x to the y. Thank you. If I have a to the x to the y, how can I rewrite that?
A to the xy.
You're literally multiplying the two. So in other words, if I have 2 cubes times 4, right? If I have 2 cubes times 2 to the 4th, I can write that as 2 to the 3 plus 4, which is equal to 2 to the 7. But if I have 2 cubes to the 4th power, that's the same thing as 2 to what power, friends?
12.
2 to the 12th. Thank you. Okay. So this is going to be 2 to the 12th power. And then one of the other laws of exponents is we have a to the x divided by a to the y. And when I have a to the x divided by a to the y, what can I do to my two exponents there?
X minus
Minus
y.
y.
Okay, good. Okay. So that means then if I do the number divided by 2 to the 4th, it's going to give me 2 to the 3 minus 4, which is equal to 2 to the
Negative
1. Uh-oh. How do I write that without it being a negative exponent?
1 over 2 to the first.
Yes, it becomes 1 over 2 to the first, right? Because if you think about it, the other property, I can just keep moving and moving. All right, because yeah, if I have a to the negative x power, right? If I have a to the negative x power, I can write that as
1 over a to the x.
Can I have a staring contest? Because I'll just record and then send it to you. Is that what you guys would prefer? Is that what you guys want to do that? Would you prefer that if I do a video and have you guys watch it, or do you want to be more interactive here?
It's really slow for me right now.
Is
Yes,
it?
I don't know.
Yeah,
I don't know.
lag.
I don't know why.
You keep breaking up.
Yeah? Okay. Thank you for letting me know that, because I'm not getting anything from you guys and it's hurting my feelings. Okay. So you can write this as 1 over a to the x power. We all know that. Yes? Or if
Yes.
we ab
Yeah.
to the negative x power, how can I rewrite that?
B over a to
A to the x.
B over a to the x power. Beautiful. So those are fun things that we could go ahead and figure out what it is that we need to do. But then I'm going to look over here. I had you guys do stuff in function notation. Do you remember what the first thing was? Because I'm trying to remember now. What was the first thing that I had you do? I know there were those 2 investigations for you to follow along. I believe it was, what was it? It was f of x plus 1, because we had like x equals 2 to the x power, right? We had f of x was equal to 2 to the x power, is that right? And then we had f of x plus 1, and then we had 2 times f of x. Did I hit, were those the ones that I gave to you?
Yeah.
Yeah, okay. So when you rewrote this, when you substituted in, this became 2 to the x plus 1, and this became 2 times 2 to the x power. Is everybody okay with that? Because in other words, when I have an x plus 1 here, that means everywhere I see an x, I put an x plus 1, right? So now over here, if I take this and I use that property, and by the way, let me go back over here. These properties are interchangeable. So if you're here, you can go back there. If you're there, you can go back here. So technically, I should be doing this for every single one of them, saying that however we want to make it work is how we're going to make it work, okay? So now when I come back over here, the nice thing is I can write this as 2 to the x times 2 to the first, because I use that first property that we had over here. And then if you look at these two, they're the same thing. So what you should have noticed is that those two will build the same exact function. okay? And then I believe the other one was, I think the second one, if I remember, still using f of x is equal to 2 to the x, right? And this time, I think it was f of x minus 2 versus f of x divided by 4, right? That's what we had. Those were the two that we had to compare. So when we went and compared them, we had to the 2 to the x minus 2, and then this became 2 to the x over 4 when we substituted it in. And again, using those laws of exponents, we can write this as 2 to the x times 2 to the negative 2. Or we could even go ahead and move this down a little bit, some space, f of x over 4. Or you could have done, because this is subtraction, right? Because this is subtraction, so you could have used this subtraction and rewrite it as this over this using the laws of exponents, okay? So using those laws of exponents, we can easily take this and rewrite it as x over 2 squared. Last time I checked, that gives me that, and that gives me that. So interestingly enough, those two yield the same exact thing. So this in terms of function notation, that in terms of function notation are the exact same thing. And that's what I wanted you guys to know and understand. Okay? Then I had you do problems where you used your laws of exponents to see what would happen with those functions when we started to manipulate them. So I'm going to go to the back wall. I haven't been there in a while, so let's go. You guys might be like one of the last classes I ever teach in this room. Isn't that something? Okay, so back over here, I think it was, if I go pull it up, I'm going to go pull it up and just say it out loud. So over here, it says that you were given an f of, that doesn't work. Oh, I love that. You're given that f of x is equal to 2/3 x. And then you want to see if f of x plus 4 is in fact equal to 15 over 81 times f of x. So we're not solving for x. We are literally just using function notation to see if what we've got is what we've got. So if this is 2/3 x, and then this is going to be 16 over 81 times f of x plus 4 means that we're going to take this, and if I do f of x plus 4, that's going to be 2/3 times plus 4. So again, if we use our laws of exponents, we can rewrite this as 2/3 to the x power times 2/3 to the 4th power, right? So that's 2/3 to the x power times 2/3 to the 4th power. When we have 2/3 to the 4th power, it means both these are being raised to the 4th power. So when I do 2/3 to the 4th power, right, I am getting 2 to the 4th over 3 to the 4th. And 2 to the 4th is 2 times 2, which is in fact 16. And 3 times 4 is 3 times 3 times 3 times 3, which is 1. So this is in fact doing 2/3 x times 15 over 81. So Jolie is correct because f of x is equal to 2/3 to the x power, so that actually does work. So that was one of the things that you should have noticed, that all you're doing is using your laws of exponents to rewrite something in function notation. So now over here, you're asked to determine on number 2, because I'm pulling up number 2, and we're going to move a little bit. And I hope that this is space. This is, now it's again, we're still using f of x equal to, is it still slow, you guys?
Yeah.
Yeah.
Just bear with me.
Yeah, it is.
Okay to follow me? Are you guys okay to follow me though?
Yeah.
Okay. I appreciate your patience. I apologize. I don't know why it's so slow because I'm at school. Anyhow, we're over here, so we want to see if I do f of x minus 2, if that actually yields 1 over 64 times f of x. So over here, if I do it, so if I do f of x minus 3, again, I'm going to do my 2/3, right? That's supposed to be here. 2/3, and then the x minus 3 here. So that's going to be equal to 2/3 to the x power times 2/3 to the negative 3 power. Okay? The desks are in the way, you guys. Remember the desks, the quads we had? Okay? So what I'm going to do is I'm going to take this right over here, and I'm just going to come on up. So I'm going to come on up. And now I have my f of x minus 3, we said was equal to 2/3 to the x power times 2/3 to the negative 3 power, which I'm flip that up. 2/3 to the -3 power. I hope all of you beautiful, amazing, and wonderful individuals are saying to yourself, hey, Sishwa, we can easily rewrite that as 3/2 to the 3rd power. Again, using your laws of exponents. That's the whole point of this. So that should be an X there. So by the time this is all said and done, we have a 2/3 to the X power times 3 to the 3rd is 27. So this winds up being 27 over 8. So whoever, the original question was, does it equal, 1 over 64? But no, it does not. It actually equals this. So this is what f of x minus 3 is going to equal if you actually use your laws of exponents. Okay? You hanging in there, folks?
Yeah, it's really slow.
I'm so sorry. I don't know how to make it go faster. Okay, so you're given that g of x is equal to 3 to the 2x and h of x is equal to 9 to the x. And your goal is to say, are they the same function, right? Your goal is to say, are they the same function? Okay, so are these the same? That's what we want to know. The same? That's what we want to know. Are they the same? And in fact, they are, because if you take g of x, and if g of x is equal to 3 to the 2x, you can rewrite this as 3 squared to the x power. Because again, you're taking your log of exponents. Remember, you can go back and forth however you want to go about what you need to do. So that will in fact equal g of x is equal to 9 to the x power. So h of x and g of x are exactly the same. Okay, moving on to the next one, which was 4. And it's saying, will g of x plus 1 equal h of x plus 1 in number 3? So I want to do g of x plus 1 versus h of x plus 1. So I'm going to move on over here. And again, I apologize if this is slow. It'll be interesting to see how this all turns out. So this is going to be 3 to the 2 times x plus 1, because remember, you have to use parentheses, versus 9 to the x plus 1. So we're trying to see if I do g of x plus 1 versus h of x plus 1 to see if they're exactly the same. And if you multiply this through, you wind up with 3 to the 2x times 3 squared. 3 to the 2x plus 2, which you can write as 3 to the 2x times 3 squared. 9 to the x plus 1 is 9 to the x times 9. So this just winds up being 9 times 9 to the x. But if you look at this one over here, 3 squared is 9. You still have 9 times 3 to the 2x. And again, you can take 9 and do the 3 squared to the x power. So that becomes a 9. So this winds up being 81 to the x power. So when you do g of x plus 1, it gives you 81 to the x power versus this one over here, h of x plus 1 is 9 times 9 to the x power. No, hold on. No, I'm wrong. You guys should have called me out. So this is, let me go back here. So this is 9 times 9 to the x power. So in fact, they will give you the same thing. I'm so sorry about that. So yeah, this is 9 to the x, or 9 times 9 to the x. They are in fact the same exact function. Okay? So remember, the purpose of this whole thing was to just enlighten you to understanding function notation. So something like number 5, you're not asked to solve for x, you're asked to determine if the two functions are the same. So some of you are asking, like, I don't understand. All you're trying to do is use your laws of exponents to determine if the two functions are exactly the same, okay? So if I'm looking at something like number 5, so if I'm looking at something like number 5, this is 5 to the negative x. So technically, this is 5 over 1 to the negative x. So you guys recognize that if you want to rewrite that, that certainly does become 1/5 to the x by using that one law we were talking about. So yes, they are the same function, okay? So let's move on to something like the next one, where things get really cute. And then it's saying simplify k of x equals h of, okay, so we're doing the next one, so, oh, what a horrible sound, okay. So it was k of x equal to 3 times h of 2x. And your only goal to find out is to find out what does that yield, okay? All you care about is what does this yield? So it's k of x is equal to 3 times h of 2x. So h of x is equal to 1 to the x power. That's what it's equal to. So that means we're going to multiply 3 times the function, and everywhere we see an exponent, it's going to be of 2 to the x. So this becomes 3 times 1/5 to the 2x power, right? If you simplify this, again, you're going to use that one law of exponents where you can write this as squared to the x power, right? Because again, it goes back to that if you have a to the xy, you can write it as a to the x to the y power and go vice versa. So that's my whole point of that. That's what you want to do. So when you do squared, I hope you're all like, well, 1/5 squared is 1 over 25. So that's 3 times 1 over 25 to the x power. And that's what I mean, that's what k of x is equal to. So when you're doing this, you're not solving for x, you are just using your laws of exponents to understand how function notation works, okay? All right, so now on number 7, you're told that g of x is equal to 3 times 3 to the x power, and you want to find g of 3 for x. So again, all you're doing is substituting those things in. All you're doing is substituting in. So it's 2 times 3 to the negative 4x. And again, using your laws of exponents, you're going to rewrite this as 3 to the negative 4 to the x power. And in your beautiful minds, 3 to the negative 4 is equal to 1 over 3 to the 4th. You have to use, noticing we're using laws of exponents throughout this entire process. So this becomes 1 over 3 to the 4th power, all raised to the x power. And the last time I checked, 3 to the 4th power was 1 over 81, and then to the x power. That is all you have to do. You're just showing how to simplify using those laws of exponents. So I will probably give you stuff to do as time goes on, as far as trying to figure out what to do with the function notation, okay? I do want to show you one more thing, and then I'm going to send you guys off into the sunset. If I have, there you go. If I have, you all see that? 4 to the x, can you see that that says 4 to the x equals 16? What is that? Well,
Not really.
can you see it now?
Yeah.
Okay.
Yeah.
4 to the x is equal to 16. What does x equal? What number to the x
2.
power will give you 16?
2.
Hold up with your fingers if you can't do
2.
anything. 3, 4, 2, everybody? 2, good. So x would equal 2. And what if you had, what would x equal on that one?
-5.
Not negative 5.
Isn't it negative 3?
Negative 3, good.
Isn't it negative 3?
Yes, because 5 to the negative 3, you can write as 1 over 5 cubed, and 1 over 5 cubed, 5 times 5 is in fact 125, okay? So now I'm going to ask one little question that I'm going to kind of feed you with, you know, what's coming next, is what if you had something like this? What if you had something like this? Do you see how they both have the same base? Do you see how they both have the same base?
Mm-hmm.
Based on both of these equations, or both sides of the equation.
Yes.
Yep.
The base is, what's the base? How about this?
3.
Over here, the base, yeah, the base over here is 3. What's the base over here?
5. 5.
What's the base over here? What's the base down here?
Can't
2.
see. over
It's not 2, is it?
1 over
Oh,
81.
1 over
Very
81.
That's the base. So we always call that, like, that's going to be called your base. That's going to be called your exponent. This is your base. This is your exponent, right? This is your base. This is your exponent. What's the exponent on this one?
1.
On this one. Huh?
2x minus 5.
Over here. No. On this side. What's 3? 3 is 3 to what power?
1.
1. When you have the same bases, you can just take the exponents and set them equal to each other. When your bases are the same. Doesn't that make sense? Think about that. Doesn't that make sense? You can set the exponents equal to each other. Okay? You can set your exponents equal to each other. So again, we would add 5. Boom, 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 boom. And then here x is equal to 6. And then x is equal to 3. And we could check to see if that makes sense, because if we do 3 times 2 times 3 minus 5, does that give us 3 over here? And 2 times 3 is 6 minus 1 is 5, and that does give you 3 to the first is equal to 3. So it does work out. What if you have something like this, though, and then I'm gonna call it a day after I answer this one? What if you have something like this? What if you have something like this? They're not the same base. So I can't set the exponents equal. But can I write anything so that way I do have the same base?
You can write 125 as 5 to the third.
I can write 125 as, I heard somebody say it as,
5 to the 3rd.
yeah, you can rewrite that as 5 to the 3rd. And now do you see how that, now that you have your same bases, you can now set your 2 exponents equal to each other. So you have 3x minus 1 is equal to 3. And then add, what is that? You add 1 to both sides, that's 4, so you get 3x is equal to 4. So x is going to be equal to 4 thirds. And if you put 4 thirds back into this equation, right? If you plug 4 thirds back into this, you have 5 to the 3 times 4 thirds minus 1, and so that gave you 125 is your question. 3 times 4 thirds is 4. 4 minus 1 is 3. You do get 5 cubed equals 125. So it does work out. Okay? So when we meet again Tuesday, because we are going to meet Tuesday because you guys are off on Monday. We are all off on Monday for Memorial Day. By the way, is anybody doing anything fun for Memorial Day?
Not.
Nope.
Anybody going to go to the store and hang out on the beach or anything? Yes, no?
No.
Nope.
Okay.
No.
All right, well, when we come back, I'll be home. I will not be, well, maybe I will be here. I might be in this room again. I don't know. I'm helping with graduation, which is why I'm here, in addition to the fact that I am interviewing for whoever the new manager is going to be. So I'm on that team, which is why I wasn't able to see you guys all week. So, but anyhow, I'm going to stop.